Fantastic.
Well, thank you for letting me join. My name is Brian Burton. I'm the president of ATT Metrology Solutions. We are in North America, headquartered in the West Coast in the Seattle area, and then we have offices on the East Coast in Charleston, South Carolina, where we support Boeing, and then also down in Mobile, Alabama, where we support Airbus. We are heavy in the aerospace industry, which we started in 35 years ago when the company was founded, and have diversified into other industries from there. And what I'll share with you as it relates to Hexagon today is some of the work that we've done with laser trackers, and particularly the real-time feature pack component of the 1000 hertz data stream that we get from the laser trackers. And so what we have kind of built off of is some of the work in the European Union with Hexagon through multi-country and multi-company efforts to implement real-time robot correction in a more dynamic fashion than what we see on the market today. And there's been various levels of success of making the technology work, and then also trying to leverage the technology on a grander scale. And so our goal, when we started what we have called ARTEMIS, was to commercialize the technology in a productized fashion so that it's a product, not a project, results, not research. And so typically what we've seen done before was more of a project and a research project with multiple entities working together for that. And so in a nutshell, we've commercialized for OEM robots, specifically KUKA, FANUC, and ABB, the only commercially available dynamic robot accuracy solution. And right now we're seeing results below 0.1 millimeters in a dynamic full volumetric fashion. And how do we do this? Well, in a simple format, we use the AT960 with real-time feature pack with other sensors, and we create a global metrology platform. And then we use that global metrology platform to then provide enhanced machine path control. Lots of math that goes on behind the scenes, lots of software that gets written, but in a nutshell, there's two halves of the solution, the global metrology platform, and then the enhanced machine path control. And what makes it unique? Well, we have the real-time aspect of the data, which enables us to do a dynamic solution as opposed to a static move, measure, correct type of calibration. We incorporate some patented IMU technology to do data fusion with the 6-DoF feed that we get from the laser tracker, digital twins, vibration cancellation, and then machine learning are also components of the solution that we've created. One of the colleagues mentioned the 3D arena. In addition to just laser trackers, we also have the capability to utilize photogrammetry in a white cell for the metrology data, but we get the best accuracy out of the laser tracker solution. And so it's really dependent upon the level of accuracy that the customer requires of us. To give a little bit of a visual in this sense, to show the piece parts of what's involved with the system, we can either install a new robot or do a retrofit on an existing robot. We work on top of the OEM robot controller, and we do that for safety reasons, because particularly in the European Union, it's more widely accepted to have the OEM robot controller safety systems as opposed to a custom controller that the integrator may provide, which then doesn't have the years of experience and learning that the robot OEMs do for the safety systems of their robots. And then we put a control system with a real-time controller in that on top of the robot control system, which then processes the global metrology system data, and comparing the commanded position to the actual position, we then feed a correction within 4 millisecond increments back to that robot controller to give full dynamic path correction. We see lots of applications for things. Certainly there's many things in the world that you can do with a robot that you don't need additional accuracy for. But there's many things that we do find, particularly in aerospace and some cases automotive and the higher precision applications, that we do desire to have better accuracy than what we can get out of a standard robot. Such things that I've done in my career: fiber placement, automated fiber placement, a lot of drill and fill in the aerospace industry, anything that requires milling or cutting or deburring And then this technology not only applies to robots, which we've productized it on, but it also applies to other machines in a general sense that one might want more accuracy from, including AGVs or drones in different positional accuracy types of applications. And then so far we've scaled this up, as I said, on 3 different brands of robots. It can be scaled onto more. What we find is every type of machine has just a little bit different flavor of communication. And so as we scale it further, it's really the work of just setting up the technology to communicate with that style of machine and the particular controller that that machine uses. And even within robots, we find that KUKA and RSI versus the FANUC platform versus the ABB platform, they have just a little bit different protocol and methodology of communication that we have to do. And we found that from the robots that we've baselined and found 2 millimeters of accuracy out of the box. With our dynamic calibration, we're getting the 0.1 or below for full dynamic accuracy throughout that path. So just excited about that and what that has allowed us to do for accuracy applications with the real-time feature pack controller. And we've been using Hexagon products across the full suite between CMMs and T-scans, now AS1s, moving on to AS1 XLs, and various components as both an integrator and a service provider in the metrology industry for the past 35 years. So we've seen the evolution of products, and that enables us as an integrator to then give better solutions to our customers. We put together different piece parts for finding the right fit of automation and streamlining the process for the end user to both collect data more efficiently and then process that data more efficiently so that there's not what we like to call analysis paralysis in a lot of cases for people to make decisions on the data that they're getting out of the systems. And then if there's any other questions or people want to dive into that anymore, here's my contact information and happy to explore further with you.
So thank you very much. Is there any question from the audience? I think it's really powerful, and we see also there is a demand in the market to have this kind of solution. Can you elaborate a little bit more what the IMU fusion data is? Can you explain what this is?
Yeah, the IMU gives you great rotational data, very precise rotational data. And when you add more sensors in to your global metrology platform, it gives a more robust answer for the data that you're collecting. In essence, if you were to lose line of sight as the robot is moving from the laser tracker, it gives a secondary data feed that you can still understand the positional data from the IMU for periods of time. Obviously, there's drift involved. XYZ, it starts to lose over time with drift, but rotationally, it's very accurate. And so in essence, we can do some weighting of the data feed for priority of it and make the metrology data that we get from the global metrology platform more robust with additional sensors.
Impressive. Thanks for sharing. Nick, question from your side?
Yes, I mean, really impressive what you're doing, and I think I know your company from a long time ago, somehow, indirectly, somehow, from hearing from you, from my US colleagues. Are you also very active outside of the US, or is main target to be active within US?
We have an expanding footprint. I would say right now it's more in work and in development to expand versus we've been in Europe for years and years. So we have done international work, but I would say it's more of an initiative to grow internationally, particularly with this ARTEMIS solution where we see the need for it even internationally than what we've historically done. I would say, you know, if I go back in the history of the company, it had historically been more of a service company, which is somewhat geographically limited, right? Because you have to send people there. Whereas now we've done more high-end integration efforts, which is much more feasible to do in a wider area further away from home.
Okay, so thank you. Thank you.
Thank you so much, and thanks for sharing. And on your first slide, you directly showed the Kraken solution, and I'm very happy and pleased to have from ITIP Jose Antonio